Okay, this is a section on Sage now, and as you're moving forward through the course, you should start to consider that the problems that we present to you can certainly be done using a computer algebra system. And sometimes it's best to use a computer algebra system because the computations are quite difficult. Now, this is an example that I believe we did in class. Let me just make sure of that. Yep. We did example number 3 in class. And what I want to claim is that it's certainly something that would lend itself to using a computational device. So what I want to do is just simply talk about this problem and then go right to the Sage code for it. All right. So what would you do in Sage code? A couple of different things. And one thing is you define a function, and that's the function over here, 8 over 2 plus x squared. You would define its derivative. And what I mean by that, you'd store it somewhere. You would define this thing, the delta x, to be that number, and then you do the computations that you're expected to be able to do with those numbers. All right. So I'm going to go to that, and I want to go to the Sage. I'm going to scroll through this. I know it's difficult. This is a section of the notes where calculator use is not absolutely essential, but it's somewhat essential. So I'm going to go to Sage now. And I'm going to type this stuff in, but I do want to go back to that problem. So reset. I'm going to define x as a variable. I'm going to now assign f of x. It's a function. The equal as an assignment operator. And I'm going to start the function. What was the function? And we'll go back and look in the notes too, make sure that we're doing the right problem. 2 plus x squared. All right. We're going to find df to be the derivative of f with respect to x. Let's do that. So derivative, diff. And we're going to take the derivative of f of x. Whoops. With respect to x. All right. So next thing we're going to do is delta x. This might look strange to you, but we'll go back and read it. All right. And we're assigning to delta x now. I'm sorry. Yeah, delta x, I'm sorry. A minus 0.5. Again, we'll go back and look at the blue area later. All right. We're going to do delta f now. And what's that going to be equal to? Well, f at 1.5 minus f of 2. Okay. And then we're going to do another assignment. Again, I'm going to type this in and we'll go back. Type that in, we'll type this in over here. And I'll type this in as well. I'm just going to be copying. And it's certainly not to bore you with the details of copying, but you should be able to do that. Let me go back to the original problem. Again, some of these problems do require the use of computational devices, and you should learn how to use a computational device. All right. So let me go through this. All right. So what did I do first? I reset my Sage instance just to get rid of anything that was left over from a prior problem. And so they say, well, there's no prior problem. You don't know that. Maybe there was. We just can't remember. All right. And then what I did to find the variable x, I assigned f of x, that's right over here, to be x over 2 plus x squared. I defined the derivative. You know what I want to do? I'm going to just erase this over here. I'm going to see if I got the derivative right. So what did I say the derivative is? df of x. Let's see what it says. It says it's minus 16x over x squared plus 2. It's right there. I got that. All right. All right, let's keep going. I assigned the delta x, that's this over here, to be minus 0.05. The delta f I put down, and I don't see that here. Oh yeah, I do. It's right over here. So I assigned the delta f to be this thing over here. And the value of a was actually 2. All right, so a was 2. All right, let me just see if I got that right. All right, so the delta f. And I'm going to just copy paste. mistake there. Delta F. I can display that. And I see the number there. And what does it say? 0.549. Now my notes put down 3 decimal places, but this goes on. It really goes on. All right. So I did okay there. Let's do the approximate delta F and see if we got that right. Yeah, look at that. Right over here. Okay. And what else do we do? Well, I don't know if I put the error down, but the error is just a difference between those two numbers over here. But I think I put the percent error down. Let's go for that. And that's going to be the absolute value. All right. Let's make sure you're witnessing what we're saying. Delta F approximate. You know what? Maybe I made a mistake here. Let me go back over. Oh, no, I'm sorry. That is the error. Let me put the error down for you. I'm just going over my work. You know what? It's right over here. And let me display that. I'm getting 1 point. Yep, getting the same number they got over there. All right, using my computer to do the computation. And let's do this computation in the end. All right, I'm gonna scroll back in the notes. I just want to, I realized I copied it, but I deleted it, and that's a problem. I'm gonna go back over here. And I think what I didn't do is this thing over here. And we'll do that again. And I'll scroll back in the notes and look. All right, so again, I realize for a lot of students, it's probably easier to do stuff on a calculator. So I think we're doing number 3. And then we got this last computation over here. Let's hit the return. And we're getting 19.047. Again, the computation's right over here for you. All right, what's disappointing about is, you're starting to think about, how using a computer might help you or benefit you in doing computation. That's difficult, right? Now, granted, you probably couldn't have come up with these computations unless you studied what we've given you. But you're more than free to use Sage as a calculator, which is what I'm really doing here, with the addition that I'm using assignment operators and differentiating functions. Thank you.